Scientists around the world have recently turned their attention to an extraordinary discovery that has captured the imagination of astronomers and the public alike. A mysterious object hurtling toward our region of the solar system, previously labeled A11PL3Z, has now been officially confirmed as an interstellar object, making it only the third such visitor ever detected. This remarkable cosmic traveler has been renamed 3I/Atlas, marking its place in history alongside the first two confirmed interstellar arrivals, the elongated Oumuamua in 2017 and the icy comet 2I/Borisov in 2019. The confirmation was announced after NASA scientists and the International Astronomical Union reviewed several days' worth of observational data and concluded that the object's unusual speed and trajectory could only be explained by an origin far beyond our Sun's gravitational influence. The discovery initially emerged on July 1st when data from the Asteroid Terrestrial Impact Last Alert System, better known as ATLAS, flagged an unusual object moving through space at a staggering velocity. The system, which uses a network of automated telescopes positioned in Hawaii, Chile, and South Africa, is designed to detect potentially hazardous asteroids. However, its instruments occasionally identify objects of a more exotic nature, and this time it revealed a body unlike anything routinely seen drifting through our solar neighborhood. Subsequent investigations showed that multiple telescopes worldwide had actually captured faint images of the object as far back as June 14th. But the significance of those early detections only became clear once ATLAS triggered its alert. What makes 3I/Atlas so striking is not only its tremendous speed, approximately 152,000 miles per hour, or 245,000 kilometers per hour, but also the nearly perfect flatness and straightness of its trajectory. Unlike planets, comets, and asteroids that orbit the Sun along predictable curved paths shaped by gravitational interactions, this object appears to be moving in a motion that suggests it is merely passing through, unaffected by the Sun's pull in any significant way. Such a path is a hallmark of interstellar origin, meaning the object formed somewhere outside the boundaries of our solar system, possibly in a distant star system where the conditions of its birth were completely different from those within our own. When NASA confirmed its interstellar status on July 2nd, they also provided new details that upended earlier assumptions. While many initially suspected the object was an asteroid due to its compact appearance, NASA's latest analysis suggests that 3I/Atlas is in fact more likely a comet. Evidence for this includes subtle signs of cometary activity detected around the object, a glowing coma composed of vaporizing ice and gas, along with what appears to be the faint outline of a tail trailing behind it. These features were also noted by the Minor Planet Center of EIU, which emphasized that while the signals are tentative, they strongly resemble the kind of activity seen in typical comets when they begin to heat up while approaching the inner solar system. Despite this progress, significant mysteries still surround the object. As of now, researchers have not been able to determine its exact size, shape, or surface characteristics. Current estimates suggest that it could be as large as 12 miles or 20 kilometers across, but even this remains uncertain due to the difficulty of observing an object so distant and fast-moving. Interstellar objects often present unique challenges because their chemical compositions and behaviors do not always match those of bodies native to our solar system. For example, the first interstellar visitor, Oumuamua, displayed a strange cigar-like shape and accelerated in a way that baffled scientists until the prevailing theory emerged that it was expelling hydrogen gas generated by sunlight-driven reactions on its surface. In contrast, 2I/Borisov more closely resembled a typical comet, but still possessed unusual chemical signatures. With 3I/Atlas, scientists are eager to discover whether it shares similarities with these earlier travelers or represents something entirely new. The object's journey through the solar system is now being tracked with great interest. At present, 3I/Atlas is located about 4.5 times farther from the Sun than Earth is, placing it well beyond the orbit of Mars, but gradually moving inward as it nears the inner regions of the solar system. Its closest approach to the Sun, known as perihelion, is expected to occur on October 30th. At that time, it will come within 1. For astronomical units of the Sun. An astronomical unit, or AU, is the average distance between Earth and the Sun, equivalent to roughly 93 million miles. This means the comet will pass fairly close in cosmic terms, though still far enough away to pose no danger to our planet. Before reaching perihelion, the object will also pass near Mars, coming within 0, for Australian dollars, of the red planet. This proximity presents a unique opportunity for observatories and spacecraft currently orbiting or stationed near Mars to potentially capture high-resolution data that could help unlock further details about the object's composition and structure. The arrival of 3I/Atlas holds enormous scientific value. Interstellar objects provide rare glimpses into the building materials and processes that occur in distant star systems. Every such object carries with it the chemical fingerprints of its birthplace, frozen ices, dust grains, and organic compounds that may have formed under conditions radically different from those in our own solar neighborhood. By observing how these materials react to heat, light, and cosmic radiation as the object approaches the Sun, scientists hope to gain insight into the diversity of planetary formation processes across the galaxy. Each interstellar visitor is a messenger from a distant past, carrying clues about the early history of other worlds and perhaps even traces of the cosmic events that shape them. Astronomers are particularly curious to see how the object behaves as it warms up. If it truly is a comet, the rising temperatures as it nears the Sun should intensify the sublimation of its ices, expanding the coma and lengthening its tail. This could make the object much easier to observe from Earth with telescopes, further increasing the chances of gathering valuable information. However, there is also the possibility that the object structure is fragile. Many comets, especially those that are new to the inner solar system, have been known to break apart under the stress of solar radiation and tidal forces. If 3I/Atlas were to fragment, the resulting debris could offer an even clearer look at its internal composition, although it would also complicate efforts to model its trajectory. The discovery has rekindled excitement about the likelihood of many more interstellar objects constantly passing through our solar system undetected. Scientists have long suspected that such objects may be far more common than previously realized. But due to their typically small size and tremendous speeds, most slip by without ever being noticed. Advances in detection systems like ATLAS, combined with improved computing tools and global coordination among observatories, have dramatically increased the chances of identifying these fleeting visitors before they vanish back into the void of interstellar space. The rapid detection of 3I/Atlas demonstrates how much progress has been made in just a few years and hints at a future in which interstellar objects may be documented with far greater frequency. For now, astronomers are mobilizing resources to observe the object during every phase of its passage through the solar system. Ground-based telescopes, space-based observatories, and even planetary spacecraft are being coordinated in an effort to gather as much data as possible before the object disappears forever into deep space. This collaboration marks a global scientific effort, with observatories in multiple continents contributing to the understanding of this rare and enigmatic traveler. As 3I/Atlas continues its journey, scientists hope it will shed light not only on its own mysterious origins, but also on the broader processes that govern the formation and evolution of cosmic bodies far from our home system. Its arrival is a reminder of how dynamic the universe truly is, and how much remains to be discovered beyond the confines of our familiar planetary neighborhood. Each interstellar visitor offers a brief yet profound opportunity to peer into the unknown, and 3I/Atlas, with its unique characteristics and promising signals, may prove to be one of the most enlightening yet.